Hello everyone, welcome back. In previous lecture, I explained about the sigma comparators. Here you can see the figure of the sigma comparator, which was having the knife edge and a Y fork or arm with a drum and a metallic strip. Then after sigma comparator, we have seen the advantages of the mechanical comparator, advantages and disadvantages. Then the mechanical optical comparator, which was the optical principle of the reflection working principle, which was the optical law. So with the angle of inclination, we will give the 2 alpha, double the magnification. So here in the mechanical optical comparator, you can see from the figure there were the two amplification stages. One was the mechanical amplification due to this lever arrangement, and second one is the optical amplification. So the double amplification system will be in action. So the overall amplification you can see by this. Now in today's lecture we will see about the Zeiss ultra optimeter. Here you can see the in the figure there is one eyepiece, objective lens, plunger, work part, mirror one. Over here there is one secondary mirror. Is in use ultra optimeter we will use two mirror. This one is the lamp or the condensing from where the light comes and reflects over here in the mirror and again reflects and goes to the objective eyepiece. So the double amplification will be there of the mechanical optical comparator. Now the Zeiss Ultra Optimeter, we can see it is a purely optical system which does not involve any mechanical component. It gives only light and thus the double reflection gives the higher degree of magnification. As the first mirror will give the 2 alpha and the second error mirror will give the double again 2 alpha. So the 4 times the amplification will be there. So figure shows the optical system of this type of comparator. The light rays from the lamp fall on the green filter. Green filter is the filters all the green light and filters whose dimensions is to be measured. So the air is passed over here and the pressure change variation gives if the dimension shape changes then the pressure will be changes as the gap between over here changes. So that is used for measuring or comparing. So a calibrated manometer tube is connected between the vertical cylinder and control orifice. Then the flexible pipe is used to connect the measuring jet and cylindrical control orifice manometer unit. Certain pressure air is supplied from the air compressor system designed in order to supply air at constant pressure to measuring jet. If the pressure of the air supplied is higher than the predefined pressure, some air will bubble out from the bottom of the deep tube and the air moving to the control orifice will be predefined constant pressure. The constant pressure air then passes through the control orifice and escapes from the measuring jet when there is no restriction provided by the workpiece to escape of air. The level of water in the manometer tube will be same as the level of water in the cylinder. But when the restriction is provided at the measuring jets, the resulting increases the back pressure and the level of water in the manometer falls, which vary the height of water in the manometer tube. So a calibrated scale being set beside this tube. In other words, the restriction to escape of air depend upon the variation in the dimensions to be measured. So You can see when what happens when the we do the measurement. Restriction is provided at the measuring jet and increases the back pressure level at the water manometer. Result fall down, and which vary the height of water in the manometer. So the tube is calibrated, scale is set at that particular position. So this is about the Solex pneumatic comparator. So the advantages of pneumatic comparator: there are no direct contact between comparator, measuring head, and workpiece. Hence, no wear takes place. Less number of moving part, less friction, wear, inertia. Indicating instrument can be remote from measuring unit. Precise measuring, very small. Jet of air helps in cleaning dust. High magnification, and best for determining ovality and taperness of the circular cores. And they are very suitable for measuring diameter of the hole where the diameter is small compared to length. Disadvantages: scale is generally not uniform, requires compressed air, then the comparator is not portable, as the size is bulky, less sensitive compared to electric or electronic comparator. The different gauging head are required for different dimension, and hence limited range of measurement is available. Then next type of comparator which is better than this pneumatic comparator, that is the electrical comparator. So basically the electrical comparator are known as electromechanical measuring systems, as this system employs an electromechanical device which converts a mechanical displacement into electrical signal. So the linear variable differential transformer, LVDT, linear variable differential transformer, is most commonly used electromechanical device which is used to convert the displacement into electrical signal. So the displacement is converted into voltage. LVDT is a basic simple example you might have seen in the uh, weight weight measuring devices, where the LVDT, where the displacement due to the weight is measured and converted in terms of voltage. Now the LVDT, you can see the construction consists of three coils wound on a single non-magnetic tube. There is one primary winding fed with AC supply and two secondary winding. So the secondary winding are symmetrically placed and are identical equal number of turns and are connected in series opposition. A ferromagnetic core, or are called as armature, is attached to this moving part, which is freely moved inside the magnetic tube. So here there is one magnetic tube, non-magnetic tube over here. There is one primary winding and the secondary winding on the both side, and the armature moves inside over here. So the movable core is coupled with the spindle or contact point. Now working of the LVDT, sorry. So when the AC current is supplied to the primary winding over here, the magnetic flux generated by the coil is distributed by the armature or the ferromagnetic core. So the voltage are induced in the secondary winding. Now the secondary winding are identical, symmetrically placed, and are connected in phase opposition, so that the voltage induced in the secondary winding are opposite when the armature is at reference position, and the position of the magnetic core is determined the flux linkage with the each winding. When core is placed centrally at the reference position, as shown in figure A, This is the null position. So equal and opposite voltage are induced in the secondary winding. Hence the net output voltage from the transformer equals to 0. So E2 is equal to E1. So E2 minus E1 is equal to 0. This is called as null position of the armature or the balanced point. Now a variation in position of armature from its null position produces an output in terms of voltages. Here you can see the sorry uh, as the armature moves towards the left as shown in the figure, E2 will be the voltage of secondary winding is increased and E1 will be decreased. So there will be net voltage available, that is the difference between E2 minus E1, and is similarly as the armature moves towards the right, the E1 increases and E2 decreases. So net voltage will be E1 minus E2 and is in phase with the E1. The It is observed that the magnification of VO is a function of the distance moved by the armature, and its polarity or the phase indicates as it is in which direction it is has moved. Hence, the pressure acting against the elastic element like Bourdon tube, bellow, diaphragm can be measured in terms of unbalanced voltage VO between two secondary windings. So this displacement is used for a converted in terms of voltage, and this voltage variation can be calibrated in terms of displacement moved by the armature. So this is how the LVDT works, and we can use this for measuring the displacement. It can be connected to the Bourdon tube, bellows, or diaphragm type of mechanical device. So this is it, end of the chapter, and thank you very much for listening me carefully. Have a nice day.